Greetings, Math 10 students. In this video, we're going to take a look at section 1.6, Exponents and Order of Operations. We're going to look at this from the standpoint of the questions that are asked in the Hawks assignment, but we're also going to take an overview of what exponents are, how they work, and how you're going to see them in some of the future sections. So we're going to go a little bit beyond just the Hawks assignment. So to begin with, you've probably seen exponents before. Here are some examples of expressions with exponents, and I want to get a little bit of vocabulary first. So when you see an expression like this first one here, you would read this as 3 to the 4th power, not 3 4s or 3 times 4, even worse. This 4 up here is what's called an exponent, and it's talking about repeated multiplication. It's actually a different operation from just multiplying, and we'll see a little bit more in detail when we evaluate what that means. But the number that's sort of higher up and to the top right corner of something is called an exponent. So that's the exponent in that expression. The number that's touching the exponent that's to the lower left of it also has a name. This 3 here is called the base of this expression. And I'm going to be using those terms a lot, and it's important to understand what is an exponent and what is a base just in terms of looking at an expression and being able to identify those things. You'll be asked to do that in the Hawks assignment, but you're also going to be just doing that implicitly for pretty much every question in Chapter 7. So in this next example, the way that you would read this particular expression is 2x to the 5th, or 2x to the 5th power. Please, please, please resist the temptation of saying 2x5. It's kind of corny sounding, and your professors are going to look at you awkward. You would say 2x to the 5th power, because the 5 here is your exponent. And then what's the base of this expression? It's not 2x, it's actually just the x here is the base. The base is always the thing that is just touching the exponent, and it's usually one symbol, but not always. So whatever is touching the exponent to the lower left of it. And then the 2 hanging out here actually also has a name. We've seen this before. That's the coefficient. And I don't normally make a big deal about definitions and terminology, but I am going to about these things just because these 3 pieces come up so often in Chapter 7. So it's good to know coefficient, base, and exponent. Now, last but not least in this example here, the exponent is, again, that guy that's kind of hanging out up top to the upper right. That's my exponent. I'm just abbreviated as exp for now. My base, well, what's touching the exponent of t? It's really this closed parentheses. So it can't just be a parentheses that's the base. And what I'm going to have to do is take the whole set of parentheses as my base. This is the only situation where more than one symbol will be your base. Typically, the base is just only the thing that's touching the exponent, but if it's parentheses, you take everything inside the parentheses to be your base. But the p is not part of my base. This p is, again, a coefficient. Now, this particular formula is going to come up again in section 3.8. This is actually the compound interest formula, so this is a good one to know. And the fact that the p is the coefficient and that the parentheses are a base and the t is an exponent is actually kind of important. It implies that the just the stuff in parentheses gets applied to the exponent and the p gets multiplied on last. We're going to see that again when we talk about order of operations, in a moment. But the important thing to understand is that the base and the exponent interact first, and that coefficient really just doesn't come into play until the very end. So those are all exponential expressions. That's what we're going to be working with for pretty much the remainder of this class. Let's take a look at some examples of evaluating exponents. You'll often be asked to evaluate an exponential expression, and if it doesn't have any variables in it, you can do that. 3 to the 4th power, for instance. So how would you evaluate this? Well, literally, 3 to the 4th power, what it means is repeated multiplication. It means take that base, whatever it happens to be, and write it out. Well, since the exponent is 4, write it out 1, 2, 3, 4 times, and then multiply all those 3's together. 3 times 3, well, 3 times 3 is 9. This 3 times 3 is also 9, and 9 times 9 gives me 81. So it's not too difficult to multiply out for fairly small numbers, but as you'll see, exponents get really big really fast. So it's nice to be able to do them in the calculator as well. Your calculator probably has an exponent button. If it's a scientific calculator, it definitely does. Most cell phone calculators do. You just have to put them in landscape mode sometimes. And the Windows calculator does if you go to the View option and go to Scientific. Your exponent button probably looks like this, X with a little Y up top, or it could look like this, Y with a little X up top, or in some cases it looks like this, a little pointy caret thing. This caret thing is the universally accepted symbol for exponent. You'll see that on your keyboard as well, above the number 6, and above the letters, the number 6 there has that little caret. And if you hold down Shift and type that, that actually is a perfectly good way of indicating exponents. That's actually how you type them in Hawks as well. So let's take a look at how you would do this in the calculator. You would type the base first, 3, then type your exponent button, whatever it happens to be. I'm going to do this guy. And then you type the exponent. So base, exponent button, exponent, and hit equals. And your calculator should tell you 81. So try it in your calculator at home. Make sure you've got the right button and know how to input it. Your exponent button will never have numbers in it. It's never going to have the number 2 or 3 on the actual button, and it will never have the letter E. If you see buttons that look like they might be the exponent button, but they have numbers or the letter E, it's actually something completely different. Don't use that button for this. All right, let's evaluate some more. 2 to the 6th power. Go ahead and hit pause and try to work this one out. See if you can get it. All right, what did you get for 2 to the 6th power? Whether you're expanding it and writing a bunch of 2's, well, you'd have to write 6 of them, right? 2 times 2 times 2 times 2 times 2 times 2. You can evaluate that out, or you can do it in the calculator. 2, exponent button, 6. Either way, we should get 64 here. Let's try another one. Negative 5 to the 2nd power. Ooh, this one's sneaky. So something I'm going to bring to your attention here. The base is the symbol that's touching the exponent, so in this case, my base is just the 5. The negative sign is just kind of hanging out to the left here, and that's kind of sneaky. Normally we think of the sign as attached to that number and part of that number. This is one of the very few situations that it's not. So this is going to be the same as negative, and then I take my base and I write it out twice. 5 times 5. So 5 times 5 is 25, and this will give me a negative 25. This, by the way, is actually just very bad notation. It's very ambiguous here with the bases. Technically, the correct answer is negative 25 because technically the base is just the 5. But most people forget that rule, so it's just really, don't do this. This is bad. Don't write your exponents that way if you can avoid it. The better way to write this would be put your negative sign like this, put the 5 to the 2nd power in parentheses, so the parentheses make it very clear that the 5 is your base, and then the negative sign is off to the side. Another way to think about this is that if I had put the parentheses differently, if I had written them like this, parentheses, and then putting the negative sign in the parentheses, that makes it a different answer here because now my base is the negative 5. Remember, when you see parentheses, everything inside the parentheses is your base. So now, this is saying take negative 5, multiply it by negative 5. So I write my base twice. Negative times a negative will now give me a positive answer, and the answer is positive 25 for this one. So just be careful. Make sure that if you're writing things out yourself, try to put those parentheses in there to indicate what the actual base is. Try not to write it like this, though you will unfortunately see it written that way sometimes. Last thing I want to do is take a look at using order of operations to simplify arithmetic expressions. So we're going to evaluate, not simplify, evaluate. You can think of it as simplifying, but you're going to get a nice number at the end. So really we are just evaluating. So this is a long, ugly expression here, but it's all numbers, so I should be able to perform these computations and get an answer at the end. I'd encourage you to not just type this in as is into a calculator. If you type this into a calculator exactly as it appears, your calculators are not very smart. They're actually pretty dumb about order of operations. They can get kind of most of the time a lot of the order of operations correct, but they do mess things up. So I'd encourage you to do this out step by step using order of operations, which you probably remember as PEM DAS. Please excuse my dear Aunt Sally. She's always messing up her operations and doing them in the wrong order, so just excuse her, give her a break on it. That's just a mnemonic device, obviously. It stands for parentheses, exponents, multiply, divide, and then add, subtract. And those are the 4 steps that you go through when evaluating this. In your homework post, I am going to ask you to please actually write those steps out instead of just punching it into a calculator and hoping for the best. So let's do our first step in PEMDAS and PEMDAS, and that's the P for parentheses. Parentheses come first, and we can see that the parentheses here, there's just one set of parentheses, and they say 4 minus 6. Okay, well we can evaluate that. 4 minus 6 is negative 2. Now I'm done with the parentheses. I'm going to leave them there just so that I remember that the minus sign belongs to the 2, because I remember from the previous slide that that makes a difference for exponents. So the negative 2 is my base here. I'm going to bring down the exponent of 3, the times 2, and actually I'm just going to bring down all these other symbols. So the divided by, this negative 32, and the 15 are all going to come down. And I'm just going to write them down on the next line. Kind of feels like when we were solving multi-step equations. All right, next up is exponents. Well, as we saw, there was an exponent right here. And so I'm going to evaluate that exponent either in the calculator, or you can write it out by hand if you want to do the expand method. I'm taking my base of negative 2 and writing it out 3 times. So negative 2 times negative 2 times another negative 2. Negative times negative would be a positive 4 times negative 2 would be a negative 8. So this becomes a negative 8 here. And again, I just bring everything else down. The times 2 comes down. This division comes down. The negative 32 comes down. And my 15 comes down. All right, next step is multiply and divide. And you do these together. Most people don't realize this, but multiplication and division actually go together as a team. You do them in one step going left to right. There was like a Facebook trick thing going around at one point that gave an order of operations, things like this, and said that everyone gets this wrong. And it was because people typically try to multiply before dividing, but you actually just go left to right with that. So I'm going left to right. I see a minus sign. Oh, here's my first multiplication or division. It's a division, and I just do that first. So it's going to be negative 32 divided by negative 8. Well, a negative divided by a negative is a positive. So be careful with your signs here too. That's another thing that messes people up. That 32 is negative, and the 8 is also negative. Negative divided by a negative is positive, and then 32 divided by 8 is 4. And then I'm going to bring down my times 2 again, and my 15. And now I finish my multiplication division. I see a multiplication right there, right? The 4 times 2. It's a positive 4 and a positive 2. So that's going to be 8. And it's positive 8. And I can bring down my 15 and do my last step, which is add or subtract. Well, 15 plus 8 is 23, and that's that. There's my final answer. So a lot of things to summarize here in this section. First of all, exponential expressions typically have a base and an exponent being the guy in the upper right, and the exponent being the thing that's kind of on the ground floor in line with everything else in the lower left. It's whatever's touching the exponent. Sometimes there'll be a coefficient in front as well. Exponent means repeated multiplication, so you take your base and you multiply it by itself that many times, although you can also punch it into your calculator. Just be careful with negative signs when you're evaluating exponents. And then when you're evaluating the expressions in section 1.6 with order of operations, use that please excuse my dear Aunt Sally. Be careful for little details like multiplication and division actually go together at the same time. And watch your negative signs too, obviously.